Okay, in this video, we're going to take a table, a linear table, and we are going to write that equation. We're going to figure out what equation that table would be. So we're always going to start by looking at our 0, where x is 0. So here is my x is 0, and I'm going to look at what my y value is. If it is 0 and 0, if I have two zeros together, then it is proportional. Now, another word for proportional is a direct variation. So if you see that, know that they're the same. And a proportional equation is y equals kx. Okay? It's not going to have a plus or minus after it because if it did, it'd be a plus 0 because my y is 0. All right, so my y-intercept would be 0 in this case. My slope I'm going to find by doing my change in y over my change in x. So I need to look at how are my y's changing. So 0 to 5 is plus 5, and we are looking at plus or minus here. 5 to 10 is plus 5. 10 to 15 is plus 5. Sorry, that is very, very messy, but kind of hard to write on it. 15 to 20 is plus 5. So my change in y was 5, or I can just say 5. Now I'm going to look at my changes in x's. 0 to 1 is plus 1. 1 to 2 is plus 1. 2 to 3 is plus 1. 3 to 4 is plus 1. So my change in x is 1. So here, if I simplify that, it is just 5. So my slope here is 5. So I'm going to plug that into my k spot. My equation is y equals 5x. And I can plug it in and check it. So I'm going to pick an x value. So I'm going to just choose the last one. You don't want to choose the 0 one. So my x is 4. So when I plug it in, so 5 times 4, I'm going to plug in 5 times 4 is 20. So my y is 20. So it worked out. All right, let's look at another example. I'm going to erase some of this so it gives me a little more room. All right. All right, so again, I'm going to start off by looking for my 0. There's my 0. It is not 0, 0. So that tells me that it is non-proportional. Sorry. Sorry, I had to pause the video so my dog can bark at the neighbor. Hopefully you won't do it again. So 0, 5, it's not 0, 0, so it is non-proportional, which means my equation is going to be y equals mx plus b, where m is my slope and b is my y-intercept. Well, that y-intercept is a little bit easier to find because it's whatever's across from my 0. So across from the 0 is 5. So my b, or my y-intercept, is going to equal 5. Now we find slope the same as we did on the last problem. Even though one's an m and one's a k, it's the same process. Now we did talk about abbreviation in class when we went over this. Instead of writing out the word change in y over change in x every time, you can use a triangle, which means change in y over change in x. So let's look. How are my y's changing here? Plus 3, plus 3, plus 3, plus 3. Sorry, they kind of overlapped. So my change in y was 3. Well, my change in x was plus 2, plus 2, plus 2, plus 2. Now you will notice that you have a constant on the left all the way on the x's. Plus 2, plus 2, plus 2, plus 2. Y, I have a constant plus 3, plus 3, plus 3, plus 3. If the constant on the left, if the left is constant and the right is constant, then we know that it is going to be linear. Now for my class, we are only looking at when they're both constant like that. But know that there are some parts of the table where you can look at it and it's not going by the same number every time. Okay, but we're not going to be doing that for my class. So You're good. So y equals mx plus b. So y equals, my m is 3/2 x plus my b, which was 5. Now, notice I do have 3/2. It's okay to keep it as 3/2 as an improper fraction. When we graphed them in my other video, we like it as a fraction because we can do rise and run. But if you want to simplify that fraction, go for it. Again, I can plug in my x if I want to, anything except for the 0 I want to choose, and I will get that answer. All right, let's look at the next example. All right, you'll notice for this example that I don't have where my x is 0. And I told you at the beginning that we always need to find that x0. So I'm going to have to extend my table a little bit. This table is a small little part of a table that goes on forever in both directions. So let's look at it. We are going, let's look at our x's. 4, 6, 8, 10, 12. So before this 4 would be a 2. 2, 4, 6, 8, 10, 12. And then before the 2 would be the 0. My x's are going by 2's. So I continued going by 2's but worked it backwards. So instead of adding by 2 on the left, I subtracted by 2 to get to that 0. All right, I have to do the same thing on the right. So this is going 0, 1, 2, 3, 4. So before the 0, since these are going by 1's, it would be a -1. So partnered up with that 2 is a -1. But I don't want the 2. I want the 0. So I need to work backwards another step. Notice I worked backwards twice on the left, so I'm going to work backwards twice on the right. Before -1 is going to be -2. Now I can see that across from my 0, it is not a 0. So this is non-proportional, which means it's the equation y equals mx plus b. All right, so b is kind of simple to see. It's whatever's across from my 0, which I worked backwards, and I got the -2. And then I'm going to do my slope. So I'm going to do a change. Ooh. Sorry, sometimes my screen does not want to let me write. A change in y over a change in x. All right, so let's look at my y's. These are going +1, +1, +1. So my change in y is +1 or just a 1. My x's are going +2, +2, +2 or just 2. So my slope is 1/2. So I'm going to have y equals my slope, which is 1/2 x minus 2, or you can do plus a -2, that's fine. And that's my equation. Again, I could plug one of those in. So if I choose the last one, the 12, half of 12, so half times x, which is half of 12, is 6. 6 minus 2 is 4. And it did match. It did work out. All right, let's look at one more example. And this example is a little bit different from the other ones, and you'll see why once we start looking at our changes. You'll see again, I did not give you that 0 because that is a skill that some students struggle with, is being able to work backwards to find that 0. All right, so let's go ahead and work backwards to find our 0. So my x is 2, 3, 4, 5, 6. So they're going +1. So before that 2 would be a 1. And before that 1 would be the 0. Okay? Now let's look at this side. -2, -4, -6, -8, -10. These are going -2. So I'm going to do the reverse. So before the -2 would come a 0. Ooh, I have a y0, but it's not across my x0. And then 2 before that would be 2. Because I'm adding 2 because the reverse was subtract 2. Ooh, that's an ugly 2, but that's okay. So across from my 0 is not a 0, so this is non-proportional, which means y equals mx plus b. All right. So my b, It's a little bit easier to find. It's whatever's across from that 0, which was a positive 2. To find my m, I'm going to do change in y over change in x. So let's look at my change in y. -2 to -4, I'm going deeper into my negatives, is going to be a -2. -2 to -6 is -2, subtracting 2. So my change in y is a -2. While my x's, a little bit simpler to see, are +1, +1. So my slope there is a -2. All right. So y equals my slope of -2, or -2 over 1 if you want to keep it as a fraction, plus my b, which was 2. Again, I can plug in a point. So let's use that 6 just because it's at the bottom. So -2 times 6 is -12, plus the 2 is -10. Now, if you don't feel confident with your integers, though, I very much wish that you were confident with adding and subtracting negatives and positives. If you're not, please double check on a calculator, because this assignment's not about working on our integers. It's about finding equations. So please use the calculator as needed. Hope this video helped you out.